Hello my dear students, here is your lecture on nodal analysis AC circuits. As we know that in DC circuits there are some analysis like nodal analysis, mesh analysis, and some theorems like Thevenin's theorem, Norton's theorem, superposition theorems, and source transformations. All are also applied in analyzing AC circuits. As we also know that Ohm's and Kirchhoff's laws are applicable to AC circuits. So in this lecture I will draw your attention into the nodal analysis. As you know that in nodal analysis, Kirchhoff's the basis of the nodal analysis is Kirchhoff's current law or KCL. Kirchhoff's current law is the basis of the analysis. So you have to find first of all you have to find out the what is the nodes. The node means in that point where the current divides, okay, where a current enters and divides. Okay, there is an incoming current, there will be an outgoing current. Okay, so that is known as the node. Just look the whiteboard. Now here you can see the circuit. So here this is the node and this is another node. Why these two things are the nodes? Because we have to first of all find out the reference node, that is where the voltage is 0. In that case the voltage is equal to 0 volts. Okay, and there are two another nodes where there is an incoming current and two outgoing currents are situated, and this point is working as a junction. Okay, here in this node this current and this current is entering and this is outgoing. Okay, so that is the main basis of nodal analysis, just to apply the Kirchhoff's current law. And we know that in Kirchhoff's current law, incoming current is equal to the outgoing current. Okay, we have to find out the node and rename it V1 and V2. We have renamed it to V1 and V2, and then there is in that node, that is the incoming current. Just denote this current to I1, that is Ix, and this current denote this current to I2. Okay, so I2. So look at V1. So at node V1, at node V1, not node, it is NODE, it is NO, that is DE, node, not note, NODE, node. Okay, at node V1 we can find out applying KCL. Okay, applying KCL, Kirchhoff's current law. You have to apply Kirchhoff's current law. I1 will be equal to Ix plus I2. Then we have to apply the basic Ohm's law. As we know from Ohm's law, V is equal to IR or IZ. It is impedance, it is IZ. So I is equal to, as we know, I will be V divided by Z. Okay, now just convert it in, apply the Ohm's law in this Kirchhoff's current law. Okay, at node V1. Okay, so there is 20 cos 40 voltage. So first of all transform it, at it will be transformed into phasor 20. There is no phase, so it is 20 0 degree, as there is no phase or plus degree. And then you can see there is a 4 ohm, 4 ohms, sorry, not 4 ohms, that is a 4, that is an angular frequency 4. Okay, so that has been denoted as omega. So convert the capacitance and inductance by this 4 radian per second, that is a radian per second. Okay, so just convert these two things. While converting it, take the capacitance, the reactance of the capacitance is AC is equal to 0.1 farad, 0.1 farad. So you can 0.1 farad. So you can easily write down XC will be the 1 divided by J omega C. Put the value of C here and put the value of omega here. You can easily find out the reactance of the capacitance. You can also find out the XL. There are two XLs, XL1, there is two inductance, XL1 and XL2. By applying this equation, J omega L, that is the L1, 1 Henry, and it's L1. Another thing is J omega L2. Okay, so these two things. After finding out this thing, you will get you will get the converted frequency domain circuit. Okay, now just remove all the things. Then what you can write? Okay, after converting this thing, you have to apply Ohm's law. So there will be 20, there is a V1 is here, so 20 minus V1 divided by 10 ohms, 10 ohms. Okay, and the Ix will be V1 minus 0. So this is 0, reference voltage is 0. So V1 minus 0 divided by, if it is 0.1 farad, you have to just find out the frequency in frequency domain, what will be the ohms. Okay, now I will show you. Okay, that is the finalized equation. Okay, you can now see that V1 divided by J minus J 2.5, that is, as it is J 2.5 ohms, and as it is J 2 ohms, J 4 ohms. Okay, so go to the open board, minus 2.5 J ohms. Okay, and I2 will be this. So V1 minus V2 divided by this. If it is 1 Henry, how can you go? How will be the value? It will be J4 ohms. So you have to divide it by the J4 ohms. Then you can calculate easily. At node 1 the V1 and V2, that is known as the nodal equation number 1. Then you can also find out the nodal equation 2, just applying same at the V2, at the end of V2. Okay, that will be same in V2. Incoming current, two incoming currents and 1 outgoing current. So you can easily find out these things. So after finding these two equations, just substitute or calculate these two equations, you will find out the V1 and V2. Then you can easily find out another parameters too. Thank you very much for being with me in this lesson. I will give detailed lessons in next video lectures. Thank you very much.